Okay, this is lesson 4, extra examples. I've got some extra example problems primarily to help you with the factoring and also to help you further with the division problems. So the first of 4 problems is a multiplication problem. So we're going to look through this and see what needs to be done. X plus 5 is already factored because there's not anything that x and 5 have in common. It doesn't fit the form of the difference of squares or the difference of cubes, and it's also not a trinomial. So that one's fine. 4x minus 6, however, 4x minus 16, I can see that these are both divisible by 4. So I know when I'm dealing with that part down there, starting with the greatest common factor, I'm definitely going to factor out a 4. So if you factor out a 4, remember it's like dividing it. So that leaves me with an x, and 16 divided by 4 would be a 4. So the factor still has the 4 in it, it's just that the 4 is now on the outside of the parenthesis. Alright, over here, 2x squared minus 32, they are both divisible by 2. So I'm going to start there. If I divide the 2 out, that leaves me with just x squared minus 16. This is actually going to factor a little bit further, but we'll look at it in just a minute. X squared minus 25 does not have any greatest common factors, but this is perfect square, and 25 is a perfect square, and it's subtraction, so I know this is going to fit my format for the difference of squares. So that's going to be x and x, 5 and 5, one of them plus, one of them minus. Okay, now that I've said that, maybe you can see that there's a square here. 16 is a perfect square, and it is subtraction, so that's actually going to factor a little bit further. So the x plus 5 was done. We've already dealt with 4 times x minus 4. We've already dealt with x plus 5 times x minus 5. And now we have the 2. And x squared minus 16 is going to be x times x, and 4 times 4. One of them plus, and one of them minus. Okay, this is one of my favorite things to do. I love the cross canceling where you find things to cancel. So basically anything in the top can cancel with anything in the bottom. So let's see what we've got. X plus 5 cancels with x plus 5. X minus 4 cancels with x minus 4. 2 and 4 will reduce to 1/2. Nothing else cancels, so what I'm left with is x plus 4 in my numerator divided by 2 times x minus 5 in my denominator. And that is my simplified expression. Alright, another multiplication problem. 3x minus 12 has a greatest common factor of 3. When I divide the 3 out, that's going to leave me with x minus 4. Remember x plus 5, we just saw it in the previous example actually. And we know it's a binomial that doesn't simplify, so we're done with it. X plus 6, same situation, no greatest common factor, it's good. But 2x minus 8 does have a greatest common factor of 2. And when we take that 2 out, inside the parentheses we're left with x minus 4. Alright, so what's going to cancel? X minus 4 cancels with x minus 4. 3 and 2 don't go into one another. X plus 5 is its own group, x plus 6 is its own group, so what we're left with is 3 times x plus 6 divided by 2 times x plus 5. All I did was rearrange it a little bit so that 3's in front and 2's in front, because that's where your coefficients generally go. So that's a multiplication. Now let's look at some division. In the previous video that I did, I gave one type of division problem and you didn't get to see how this really works. So starting with division, the process, the first step is to take the second fraction and flip it. Okay, so we have flipped this. Now, since this is x plus 4 and this is x minus 4, those are binomials. So that means the plus here causes the x and the 4 to be together, and the subtraction here causes the x and the 4 to be together. So I can't write this as x times 4. I can't write this as x times negative 4. These are stuck as binomials. That's how they are. I think of it as they're holding hands by the plus sign or the subtraction sign, and they can't be broken apart. So what can be broken apart in this situation? Well, we can write the x squared as two separate terms. So this could be 8 times x over x plus 4 times 2 times x minus 4 over x. Now, this problem does not have much that will cancel, but we are going to cancel what we do see. So I can take this free x and cancel it with one of these free x's. Notice this one is not free and this one is not free, so I can only cancel it with another free x. So what am I left with? Well, I have an 8 and a 2, so I'm going to write that as 16. I have one free x left, so 16x times x minus 4 divided by x plus 4. That's as much as that will simplify. Okay, now this one's got a lot going on. We have a trinomial here, so I'm going to say what multiplies to give me 27 that could add to give me -6. And I think I'm going to go with -9 and +3. -9 times 3 is -27, and that adds up to -6. So that one's done. 2x squared plus 2x, this has a common factors. They both have 2's and they both have x's. So if I factor out 2x, it really means I'm dividing it out. So the 2 divides here and leaves me with, there's just one x going to be left here, plus 2x divided by 2x is 1. Anytime you divide a number by itself, it's always going to be 1. Now remember, it's a division problem, so we have to flip the second side. And as I'm flipping it, I'm actually going to go ahead and write this. X squared can be written as x times x. It's two free x's. And then we're going to go ahead and factor x squared minus 14x plus 45, even as I'm flipping it down to the bottom. So what multiplies to give me 45 and adds to give me 14? How about 9 and 5 give me 45? And if they're both negative, they add up to -14. Alright, now we got what we wanted, and we're going to see what's going to cancel. I have x minus 9 cancels with x minus 9. That's awesome. And then I also see that I can take this free x with one of these free x's and cancel that. Now I still have a 2 here, I still have a free x here. This x plus 3 is a group, this x plus 1 is a group, this x minus 5 is a group. So my final solution is x times x plus 3 over 2 times x plus 1 times x minus 5. It doesn't have to simplify a lot for it to make it a simplified problem. Okay, I hope that helps with 8.4.